What's up, people? So I'm going to show you and explain how to make 3D endless runners in VR. It's almost the same process to make it for normal, regular mobile app games. And endless runners are things like Temple Run, Lara Croft Tomb Raiders, Relic Run, Sonic Dash, Subway Surfer. The list is endless. So even though these games and levels seem like they never end, as you've guessed, the art, the environment, the AI, the enemies, the difficulty, it's all programmatically generated. And you could even make this for Oculus Rift. You'll just get extra interaction because you'll have two hand controllers with their own axes and buttons. Whereas Google Cardboard is what I've done this one for. It only has one trigger button. So you've got to use the screen and your head movement to trigger other interactions. And you can use that one button to do two things if you really want to. Yeah, the top, before I get into it, I have also pushed this scene and all of the C# code to GitHub. I've put a link in the video and on my website, so you can download the scene and the code from there. And the usual drill, don't forget to like, comment, subscribe, share. All right, so my layout's a bit different to most people's, but this top window here is the scene composer. So, you can make all your changes in here. And this is going to be more of an explainer. I'll run you through all the code and the elements and all that. And I'll do some other different tutorial videos, but this is like an explainer tutorial. So, yeah, this top window, you can move things around and create things in here and all that. This bottom window is the actual game play mode. Yeah, it says game. So if I publish this to Google VR, say for Android or for iOS, you would not just see this one viewport, you would see two of the same looking things. That's just slightly offset, one's for your left eye, one's for your right eye. Yeah, Oculus would kind of work in the same way. So yeah, and all this stuff on the right is kind of showing you, what's either what's being clipped, what's in the hierarchy of this game area, and then on the right, we've got the inspector. Got kind of two inspectors for no reason there. And here, you can see some of the assets. So we've got the codes. We might have some prefabs and things like that. So first things first, let's do a bit of a demo. So try to look at both windows while you're at it. Okay, so this blue thing's a bike, even though it's a capsule. Every time you hit a red enemy, they die, but you get nitrous. Every time you jump, you slow down. That green thing there is the finish line. You don't have to have the finish line there. But you see, look, it's calculated the time, the score, and it's got a restarting little system in there as well. So let me see if I can get rid of that, that finish line before I get to the end. So, as you'll see, this stuff's never going to end. Let's try to get to the roads. Try to figure out what's going down here. As you can see, as this bike, this capsule gets towards the end of a road, that road then moves position. So at number 3, now it's at number 1, now it's at number 2, now it's number 3. They're all just jumping to the end maximum total position. So look, it's at 3rd place, it's going to 1st place, it's going to 2nd place, it's going to 3rd place. That's basically how it works. So if we really want to slow it down, let us, oh yeah, and all the code which you can get from GitHub, it's like, I think it's commented quite nicely. So yeah, you'll be able to figure out what's going on from there, especially after watching this video. So I've commented out the thing that makes the camera move. The VR camera's parent is called a camera rig because I'm inside the player, which is the VR camera's code. What we're normally telling it is, when it's not commented, we're telling it its current transform position, its position in the world space, plus equal means increment. So add this direction, whatever this direction is, which is mentioned up here, add that to it, and then, multiply it by speed, and we've got speed up there, and then we've also multiplied by time, but delta time, this is just to, multiply by time, and then the delta time is how the frame rates work, because, my computer is probably going to be faster than your computer, and your other person's computer is going to be faster than mine, so we can kind of all normalize. And direction is just basically what it's saying is, move forward in the X and in the Z axes, but this is confusing the thing, so we'll get back to that later. I basically told it not to move. Go to play mode, let me find a road. Let's find road number 1, and let's make that road number 1 the same color as the finish line. Where is it? Yeah, there we go. It's bright green. Finish line still there, so let's hide that finish line. Go to camera rig. So this is the VR camera. See? GVR, Google VR, pointer physics. So this is the camera. This is the bike, the cylinder thing. That's a child. Below that's a collider, actually, because I'll explain later why I put the collider below the bike. So let's go back to the camera. As I move, damn it. As I move forward, enemies spawn. Separate tangent, but when you're 5 meters away from the most recently spawned enemy, 20 meters away, another enemy jumps in. But that's not what this example is about right now. As we get towards the end of the road, boom, it jumps to the front. As we get to the end of this road, it jumps to the front. So now let's just focus on this green road. As I get to the end of this green road, it was in position 1, or position 3, now it's in position 1. Get to the end of this road. Now that green road is going to be in position 2, because you'll see exactly right here. We're on a grey road right now. We get towards the end of the grey road. That grey road is in position 1, and the green road is now in position 3. And this just can go on forever. It will go on literally until your battery dies. So let us get out of play mode and go back to, nothing would have saved in play mode, and let's uncomment that code, / comment in C#. Now, let's sort of see that from a code perspective. But before we go there, we've got a road manager. As you can see, we've also got a road manager script here. So this road manager, inside that script, we've got this array, a list, an array. I manually told it, have 3 roads. I can tell it have 2 roads. Get rid of road 3, for example. The problem you'll have here is it's just not as realistic. So let me get some nitrous. These enemies, you can see that gap. Keep looking toward that green fish, you can see a bit of a gap. There is ways to make it a bit more unnoticeable, but the easy way out is just have another road, because it ain't going to be too much load on system resource to just have 3 roads. They're not, well, in this case, they're not very heavy. It's kind of, every road is 40 meters. So I just add another 40 to that, go back to my road manager, tell it I want to have 3 roads, and it just duplicates the last item it knows of. So let's just correct that there. Let's play it to make sure I haven't screwed it up. And you will know if it's screwed up because there'll be a gap and no road. But yeah, it seemed legit. And now it's harder to see if there is a gap between roads. Okay, so in the road manager, we've also got this thing called road size. road size is something I've manually set. We could have got it programmatically by looking at the start and end point of the road, but again, it's sometimes why work hard if you can work smart. So I just manually told it the road is 40 meters. It's actually 40 F, which is floating point units, but meters for argument's sake, and a player offset. So this is the player offset. Just tell you what my comment says. It is a distance calculator, so we want to figure out the distance of between the player and the end of the road. So yeah, we're in the road manager script, and that road manager script is attached to this road manager. So yeah, we've declared a game object, and this is the, for those who know object-oriented programming, this is the array list sign. We've called it roads, so this is the array of available roads. We've referenced a player. Player means the player script, not the player game object. So this is an easier way for us to get into the code of the player. The player in this instance is the child of the camera rig, the inter-game object, and the player is the VR camera. The way you know it's the camera is you've got this little preview thing here, and it's a GVR pointer physics. That's what you need to add to your Google Cardboard's VR camera. Anyway, we've also got a road size. This is the thing that I manually entered 40 for. So the length in the z-axis of each road. So I'm sure most of the people watching this already know X, Y, Z, but X is your left and right horizontal, Y is your up and down, your Y-axis is your up and down, vertical, and your Z-axis is forward and backwards. So then we've also got player offset. This is that thing to calculate the distance. Even though it says 25 here, because it's public, I was able to, well, not me, but Unity lets you expose it in the game engine, so you can just keep changing it around. Here, so I've made it 20 here. Okay, and now let's look into the code. So I've removed the start method. So this, you've got this void update. It's called once per frame. So let's just imagine you're on a half-decent computer. You'll have, potentially 60 frames a second. This is where that delta time thing comes in. It helps to normalize between people with different frame rates. So if you've got 60 frames a second, it's going to run whatever's in this update block 60 times a second. Yeah? And then inside that, so it's a loop. So Unity creates the loop, one set of loops for you. I've created another, a for loop. So I've created a loop within a loop, kind of like Inception, and then an if block in there. So the for loop says for any road, you can call this whatever you want, you can call this cats, but for any road in roads. So we only actually have declared roads. So for any road in roads, so it's looking at each one, it's going to keep iterating. Then we've put an if block straight after that. So we're saying if the player.camera rig means if that VR player or its parent which controls its movement, if its Z position in world space, if it's forward position, could be backwards, but if it's forward position minus the position in world space of that road is greater than the player offset. So it has to be greater than, let's just make it say 20 just to keep consistency. So I'm just letting this thing load up. All right. This position is 0 because it's the first road. It's looking at the starting point. This position, it's actually looking at the midpoint. This one's position is 40. So if that player is at position 40, the road is 40. 40 minus 40 is 0. So it ain't going to create any road. Because the difference between the two, the delta between the two, has to be greater than 25. Or maybe it would create, actually it would create a road if the player is at the end of the road, because it has to be greater than 20, 25. And then what it's going to do when you get to that, when it's done that little bit of maths there, we've done the if, we've done the statement. And now we want to do the solution. So the solution is going to be, don't do anything with the X. Don't do anything with the Y off the road, the individual road. So rows within road. And this is probably the most complicated part of the whole thing. And it's only in a few lines of code. But with the z-axis of the road, yeah, whatever the current z position of that road is, yeah. So what's the z? Let's say what's the z position of this road? It's 0. In fact, we can get it from here. It's saying the current z position of the road, add the road size to it. As we know, the road size is 40. And then multiply it by roads.length. So roads.length mean the total amount of roads in that array. In this case, it's 3. So let's get back to that code. So if the difference between the player's position and the road's position is greater than the player offset, which is 20, you can see where my mouse is, yeah? Then do nothing with the horizontal positioning of the road, because it just says, leave X as it was, leave Y as it was. But with Z, you want to do 40 times 3 in this case, but it can be dynamic. You can add other things to it. So it's going to add 120 to the position. And then, as I've commented at the end of it, it says move the road to the end position of the array of roads. So if you were to move this to position 120, you'd be there. Okay, well, move the platform, I didn't move the road. So let's imagine you have to do this again. You need to move this 40 times 3. Just whenever this condition, the statement above, is true, basically, if the player's position minus the position of the road's z axis is greater than 20, do this whole calculation. To forget the x, forgets the y, and with the z of the road, and it's actually the road parent game object, not the platform itself, you need to just add 120 to that. So 120 plus 120, it should be 240. Okay, it would move there, but these other two would have had that same calculation done. So, by example, I should have done it here. So this one, they would have all been moving forward in space. If this one goes 120, the next one would have become 160. But it makes more sense when it's in play mode. So let's just kind of undo the damage that just done. Yeah. Okay, I think that's right. So let's just play all of that just so we so it all makes sense again. So this is the player moving itself, so let's get a bit of nitrous so we get some speed. So as you can see, as I get towards the end of one road, let's just zoom in here. I'll do it manually and I'll just get rid of this finish line so we can see it working properly. Let's move this finish line right to the bottom. I just put the finish line to the top because it's getting in my way now. All right, and let's comment out that player's movement. But basically, yeah, we've covered the road manager. Just doing this little spinny thing there, so it's working. All right, so let's hit this camera rig. Move the camera rig forward. As we get towards the end of this road, because of that if statement calculation, that road disappears just as the player's gone past because of that offset. And then that road moves. So this road here is going to move to the end. So all of their Z positions are going to change. So my end example was getting a bit messy because I was only moving one road. I wasn't moving one road and then the other road and the other road because, as you remember, code is saying road in roads. I was just trying to move one road and then move the same road again. So where's this camera rig at? As I move the camera towards the end, they all move. So let's start checking their positions. Their positions should have updated as well. This one's position is now 40. In fact, no, it's not. Its position is 160. Yeah. Road 3's position is 200. So road's 1 position must be 240. Yeah, it is 240. So if we then move camera rig a bit forward, this road here, which is at 160, is going to move to about 280 because it's going to add 120. It's going to add 40 times 3. Right, let's see some evidence. I believe it was road 2. Yep, it's 280. And, you know, another way if we really want to understand it is just drag this green thing onto there. It's in play mode, so it won't really save, which is good. I'm going to move forward. This one's position is still going to be 280 because this one wasn't affected by the code. The one in front was affected by the code. So if I go to camera rig here, the grey ones have moved. This green one is still going to be 280. But now, this green one is going to move to, I think, 400. 280 plus 120. Yeah, it's going to move to 400 once the camera goes towards the end. So let's just highlight that road. So this green road is going to move to 400. Boom. Let's see what's going on. Yep, it's moved to 400. So that should explain how the endless runner side of things are, at least from the road perspective, how it's working. I suppose the next thing that endlessly generates, oh yeah, and just to reiterate, the way that the road is made is you've got an empty game object. It's just a nothing. It's literally an empty. Inside it, we've got a platform, which is the actual road. I've even put a tag road in case we want to start, you know, looking for tags of collisions or raycasts and, you know, things like that. There ain't even a script in any of this. All the script is in the road manager. Then you've got these stripes. So you can start putting whatever things you want. So the stripes, these, you know, the white stripes that you see on roads around the whole world. And yeah, that's how the roads made. The enemy, I initially put the enemy in each road, and then I also put the enemy in the road manager, but then I couldn't dynamically just spawn them. I had to kind of create them manually and drop them on like I've created these roads. So I could even make these roads into free prefabs and generate them. But what we've got with the enemies is the setup scene is something for a different tutorial I'm going to make about how to actually set up Google VR and make some like mini teleporting type of environment. The enemies are prefabs, so the script will call them. If I was to just dump one here, oh, it's a bit far away. And the enemy has its own script on it. So let's actually look at how these enemies are being created. You can delete this enemy off here. If we go into the game manager, the game manager mentions, you know, it's got an enemy prefab reference. It's also got the player's code reference. It's got spawn distance from the player. So this is a float, I can tell you that because I made it. But it means 20 meters away from the player, something's going down. And then you've got this one here, which is spawn distance from enemy, which means 5 meters away from the enemy or before the enemy, something's going down. So as you can probably guess, if I start to move this this player along, I'm not in play mode, so I don't want to do anything. Enemies are just going to start appearing and then disappear because, you know, to save RAM and things like that, you want these enemies to just hover about here for about 5 seconds. They start to disappear if you haven't collided with them. So look, an enemy is created when there's a virtual enemy pointer. When I'm 5 meters away from that enemy, 20 meters away, another enemy is created. Then they are created with random range, so random X and Y. Gosh. Let me get back to my player. It's not SQL. It just popped up. So yeah, enemies are just going to endlessly spawn. And yeah, it's basically that simple. So let's just sort of also fix some damage that we've done. Let's put the finish line back in. Let's try. Just leave it up top. Okay, so we know the game manager to do something with the enemy. We also know that the enemy has its own script. So let's start having a look at what's going on. Inside the enemy, there's a lifetime. 6 seconds here, but it's 5 seconds when we're in the prefab because you can change it. And this is the countdown script. So in the update, again, I've deleted the start method because we didn't need it. So it's what it's saying is, let's assume the enemy lifetime starts at 6 seconds. It's going to minus equal, so it's going to decrement. Is that the word? It's going to take off, 1 second every second. So it's going to keep counting down. So it's going to say basically if, and this is attached to each enemy that appears. So if we play the real thing, let's let it load. You see the spinny thing in the bottom right. I think this should load it up, huh? Every single one of the, let's get rid of the finish line. Okay. Every single one of these enemies that's created has its own script to it, has its own lifetime. Let's find another one. Has its own script, has its own lifetime. Yeah. So yeah, lifetime starts at 6, goes down approximately 1 second per second, because Unity gives you this time function and it gives you a delta time function, so you don't have to worry about that. You can even click into this and see how they've coded it up, or what they've used. So if it is less than or equal to 0, if the lifetime is less than or equal to 0, it just destroys that game object. But also, if this is an on trigger enter, so we've got a trigger collider going on as well. If bike collider target, I'll show you what that is. Underneath the bike, I've made a collider. The reason I've had to make a separate collider and not put it into the bike is it was a bit long to do that, because if you add collision, or if you basically add the collider, what's it called? If I add this collider to the bike object, this capsule, and I make it a trigger, it falls through the floor. So the easiest way is just to make, I'll show you. It's just to do with like the way the physics and the collisions work. It's like, it's gone. So game over. So it's just easier to not make your bike your trigger and just make a separate collider that's a child of your bike, that's attached to your bike, and make that the trigger. And that one doesn't have the physics on it, and it doesn't have to follow the rules of gravity. So yeah, those who know Unity already know this, and those or Unreal and whatever. But those who start to play with it, that's a quick hack. Just make the child of the real object have the collider to it, and then the laws of gravity don't apply basically, or the laws of physics don't apply as much as well. So yeah, we've got this on trigger enter collider thing going on, and what it's saying is if bike collider target, that's what I was supposed to show you. The name is bike collider. I didn't even reference the tag, so I just referenced the name. If the transform name, so this is the transform, if the transform name is bike collider target, this is just commented out code, just console, just to see if it's actually working. Destroy this game object. So you're destroying it if the enemy has just been alive for 6 seconds and no one's hit it, or if somebody hits it, destroy. But we collect the score in another place. You can't really collect score or score, add to a score variable in a prefab instance. So this is a prefab instance. It's not actually part of the hierarchy. It's coming from somewhere else. And then it's like a fake. It's instantly generating it in, and then you're destroying it. So the score for some reason just never saves. So you capture the score in an object that's not going to die. For example, the player doesn't die. The bike doesn't die. It doesn't get destroyed. So you can capture the score there. Okay, and then in the game manager, we've got an enemy pointer. It's just like a virtual, kind of like a calculator to figure out something to help us figure out the distance from the player to the enemy. So let's just add that there. So then the people on GitHub will understand this a bit better. Calculator for distance of player to enemy. So we can ignore all of this stuff here. Yeah? We're just focusing on this bit right now. We're just looking about the enemy. So in the game manager script, we have put the enemy prefab in there because we want this to be spawned. So what are we doing here? Setting when to spawn enemies. So if the enemy pointer is less than the player's Z position, then we want the enemy pointer to increase by the distance from the enemy. So where were we? If the enemy pointer, which we haven't really declared any number to, if it is less than the player's Z position, set it to the 5F. Yeah, set it to 5 meters away. Then dynamically start to generate enemies. Yeah. So first we're going to do this thing here. This is how we instantiate the prefab. So we make an object called enemy object, then we tell it to instantiate the enemy prefab, and the enemy prefab has already been dragged into the editor. And then we're going to tell it to transform the position of this newly made game object, which instantiates the prefab. What we're telling it to do is make the new position of this be on the x-axis. So it has to be, a vector 3 has to be x, y, and z. So x is in your first comma, y is in your second comma, and z is in your third comma. So it's going to be between minus 4f and plus 4f. So that's almost the left edge and the right edge of the road. The y is basically 2.5 meters, 6.5 meters in the ground. As you saw, when you look at them, some appear high, some appear a bit lower, but basically they're never going to appear less than 2.5 meters in the ground, from the ground, and more than 6.5 meters. So this is a standard spawning thing. You could use this for any game, not just Endless Runner. I'll make another tutorial of how you can make enemies spawn around you in a circle, like a radius, but this one it's more like the z-axis. And then what we're telling it to do is look at the player's current Z position and make this, so the player, the VR, your headset, wherever you are in the world space, and then make this red enemy appear at this thing, yeah? This much away from you. Spawn distance from player. So what is spawn distance from player? Is 20F. So basically, if the enemy pointer is less than the player, so whenever that calculator is less than 5 meters away from the player, make it 5 meters away from the player. So every time the player gets 5 meters away from an enemy, 20 meters away another enemy is created. I probably didn't explain this in a good way because I don't know if you can see my clock, but it's gone midnight. So yeah, that's basically how the enemy is generating. So yeah, it's a bit of a mind boggle, politest way to say it, but that for each loop, and which has a calculator, distance calculator in there, and this basically an if statement mixed with some basic math in an update loop for it to keep running with a bit of instantiation, which is a standard thing in game development, is what makes the road keep generating and the enemies keep generating. And again, these concepts don't have to only be used in endless runs, but yeah, just before we jump into the player, let's see that again, because I think it will make more sense for us now. I'll keep the finish line there for now, so that the game actually has an ending point. 5 meters away, 20 meters away, another enemy pops up. So 20 meters away, an enemy pops up. Should probably slow it down for it to make a bit more sense. But every time I'm 5 meters away from an enemy, another one pops up 20 meters away. If I try not to hit any enemies, then the acceleration of the player is not that fast. So we should be able to see it. In fact, we could probably see it better on this top. 5 meters away, 20 meters away, enemy pops up. 5 meters away, 20 meters away, enemy pops up. And it's just running in that loop. It just looks random because of the X position is going to be between the left edge and the right edge of the road, and the Y position is high and higher up. Yeah, that's that. I think the next best thing to look into is, should probably cover this one after, but I'll cover it now because there's barely any code in here. So the bike collision is what I have attached to the child of the bike, as I mentioned, yeah? And I've called it bike collider target. I've put a tag of bike on there. And it's just got the script, yeah? The bike collision script. I've referenced the player, I believe as a game object, and we referenced the enemy refab in there, not game object. Actually, yeah, we referenced the enemy's game object and just drag the prefab in. So what's going down here is we can ignore this. I've just found the player by code instead of, you don't have to, even if I didn't drag it in here. I've done this nice little piece of code that will also just automatically add the player in. When we start, see, it just automatically added the player in, where thanks to this bit of code where we're saying this game object I've talked about here above my whole script, or at the top of my class. I've told it player equals, this is a standard thing in Unity, like game object dot find equals player. So it's going to look in the throughout the hierarchy for this. So anyway, this was just a bit of fluff. What's really going down is over here, which is on trigger enter. It's that old trigger thing. When I pressed it on the blue bike, it fell through the floor. But on the capsule collider, it's just like an invisible type of physics, you could say. On that capture collider, if the bike collider hits something with the tag of enemy, so this enemy has a tag of enemy, so if the other collider is the variable of the collider, if it hits the enemy, this debug is not running because I've commented out. What it's going to do is first of all, it's going to update the player's speed. So inside the player, the speed. It's going to update the player's speed by the boost, which you could also call nitrous. So if we go back to the player, so I'm using the bike collider script to go into the player and then change the axis script in place. It's going to add 0.25 F, let's call that miles per hour. So a quarter of a mile an hour. Something like that. And then, so yeah, basically, long story short, every time the bike hits the enemy, the speed is going to go up of the VR player. The score is going to go plus plus. Plus plus just means plus equals 1. So it's going to add 1 to the score. Remember, I have to add this. I have to do this collider twice. It's so long, but you have to have the collider if you want the score to go up and you want other things to properly save. You've got to add it to. Well, that's what I find. There's 2 ways to do it. You can do a lambda script, a delayed script where you do like some sort of an action that's kind of waiting for the signal coming in. It's proper long. I've posted it on the Unity forums. I've put some solutions out there for people who were not able to increment scores because their game object keeps being destroyed because they're asking to be destroyed. So you can do some lambda function. It's just long. Another way is find a game object like this that you're not destroying and add the thing you want to save when the other enemy is destroyed. Just do it in this script that's into this object that's not being destroyed. So yeah, we're going to increase the score, increase the speed, we're going to increase the score. And then we've also, we're telling this byte collider else. So, not disregarding this because it's not an else, it's an else if you hit something called with a tag or finish line. Now remember, you manually set tags on what you want, so it's not going to be a mistake. If it hits something with a tag or finish line, we're going to update a Boolean value inside player as well to true. A Boolean is a true or false thing. So I think it was reach finish line. Yeah, reach finish line. It starts off as false, so we're going to set that to true. And then somewhere else in this whole set of 1, 2, 3, 4, 5 scripts, when reach finish line is true, it will change the state of everything else. So that's what byte collision does. The messiest, not the messiest, because it's quite clean actually, but the biggest set of script is in player. So let's go to player. Inside player, we have referenced the camera rig. To be honest, I don't like to do this, but you have to do this with the newer versions of Google's VR's SDK. And I'm not using their newest version because their newer ones, I've put in GitHub what version I'm using. It's 2.00 or 2.0.0. The newer version of Google VR's SDK, to be honest, they've just kept effing it up a bit. They just made it harder and harder and more code to get things, the basics to work. So the reason I use this version is, you don't have to code just to get like basic things like this little this white dot. It's the reticle pointer, or this head movement. I'm emulating head movement by pressing Alt, and I'm emulating like head movement by pressing Control here. The newer the Google SDK, they expect you to make all of those scripts yourself, which is just, again, it's not working smart. It's a waste of time. Anyway, because I got slightly new SDK, I have to put the player into as a child of a parent object, and then I have to control the movement of the parent object. So it is bloody long. Like I have to keep referencing like camera rig dot transform position instead of transform dot position. But it is what it is. So yeah, we've referenced a parent game object, and then I've brought it in by a code, just because I'm used to that. So I've told it, the camera rig here equals game object dot find equals look for something called camera rig in the hierarchy. But you don't have to do that. You could just like straight up, if it wasn't there, you could just like drag that in there. Yeah? And then we've also referenced the bike. The bike is that blue capsule thing. I could just replace this with like a 3D OBJ or something like that of an actual bike. But I just kept it as a capsule for now. It kind of moves better in this whole endless world, like the way you can make it drop and jump and drift and all that. I'll show you. If I was to have actually added in my motorbike, let me just get some more speed. I can't get it to do like, let's not do it now. I can't get it to do like stupid things like this, like flip around and still move forward. I'd have to like add loads more code and like a directional vector pointer. And so for the purpose of this tutorial, it was easier. for explainer, not tutorial. Okay, so in the player, this bike distance, it's not used. It was just something I was messing around with before. We've got speed. You can guess what that is. You've got a max speed, because if I, and these are all public, so you can change them in the editor. Max speed is 55. So the thing is, it gets a bit bonkers the faster you go, but when you're actually wearing VR, it is quite jokes. And especially if you move the finish line further along. So, again, you can move the finish line from here if you don't do it by code in the game manager. So, so you've got an acceleration. Down below, it's going to talk about how the acceleration works. And I think these values here are probably different to what I've got in the editor, because as you will know, you can set some things here and then it only kind of works for the first instance. Then you've got to keep changing in the editor as you experiment. You've got deceleration. To stop this game reaching max speed really quick, every time you jump, it takes a bit of speed off. But every time you hit an enemy, you will get a boost. I think the boost is bigger than this in real life. Yeah, the boost is like 2 miles an hour in real life. That makes sense. Not a quarter of a mile an hour, because that's not really going to be that good. Yeah, so you've got these speed controllers. You can say speed, max speed, acceleration, deceleration, boost, called in different instances or times, events. You've got a reached finish line. We kind of talked about that. That is a true or false. It's a bool. Those who know coding already will know what this stuff is. So yeah, we're going to, we start reach finish line as false, and then the game works. As soon as it's true, we can start to disable things, basically. There's better ways to disable than I've done it. My code is not efficient. It's purposely not efficient because it makes it easier to understand when there's a bit more of it sometimes to start with. So we've referenced the bike, we've referenced the camera rig here, but you could just drag them into the game object, which is an easier thing to do. So what we're saying is, and like I say, it's quite well commented, this stuff here. So what's going down now in this update method, as you remember, the update method is called once per frame. So let's assume it's called 60 times a second. That should be like 3,600 times a minute. For example, it's going to keep looking for this code. Or keep scanning and implementing this code. So the speed is going to increase, plus equal. It's going to increase to whatever it was by acceleration, and then it's going to multiply by over time by delta time to kind of, I would say, normalize the time based on your frame rate. So if you're playing multiplayer, if your computer's shit and mine's not, the time codes, if your computer crap, mine's not, it will try to make everybody kind of have that same equal time. Otherwise, if my computer is really fast, I could just shoot you a lot quicker than you could even dodge my bullets. So that's what delta time is. Not the best explained way, but it's one, potential explanation of what it can do. So if we look at the acceleration, we're doing 0. Let's imagine this is miles per hour. We're telling it max speed is 55. Your starting speed is 3.7 mph. Your acceleration is almost half a mile an hour. Your deceleration, every time you jump, you lose 2 miles an hour. But every time you hit a red object, an enemy, you get 2 miles added to you. 2 miles an hour added to your speed. But sometimes when you jump, you might hit like 5 enemies or 3 enemies at once. So, it's worth the risk sometimes to jump and lose 2 miles an hour if you're going to get, if you're going to hit 3 enemies. So you'll be at least 200% better off if you do a good jump. So even though I jumped, not this time, but the time before, as I landed, I still hit 2 enemies. So I didn't slow down, but if you keep jumping for no reason, you slow down a lot. So where were we? Speed plus E equals acceleration minus multiplied by time. So every second, for example, speed is going to go up. If speed hits the max is greater than the max speed, 55 miles per hour, for example, the speed is just set at that max speed. Your speed can go down when you jump. So it will still have some sort of natural effect to it. It won't just, because once you keep going at the same constant speed, if you can't see anything, it's just like, it looks like nothing's going on. We've created a directional vector, and the purpose of this is to only let the player move horizontally, because otherwise, if you don't have this here, and you, let's see, if you go vector 3 dot forward, which is 0, 0, 1, you will start to move like a plane. Okay, bad example because I think the bike is not gonna have that physics attached to it. Okay, bad example, forget that. But basically, there is a way where you can get it to move like a plane if you don't do this. Actually, let's give it one. Let's give one more attempt while we're here. Just show you what I mean. And if not, you can just believe me. But it probably won't work because this bike has got gravity attached to it and other things. So yeah, as you can see, okay, the bike's just going completely like skits right now, but I'm flying. So yeah, you're on an endless runner on a road. Oh shit! You're on an endless runner on a road. You don't want to be flying unless it's plane type game. So that's why we've created our own directional vector, and then we have told it 0 on the y. Because remember, vector 3, then you've got your brackets. You have to do x, y, z. So we've just basically told it nothing allowed on the y. So let's just, I think we've added in whatever we've removed. And again, because I'm using a slightly newer version, not the newest version of Google Carbon SDK, it brings up these console warnings, but it doesn't matter because it will still, you can still export to Android. And if you get a slight, you know, if you get the old enough version of Google SDK, you can export to iOS, Apple. Yeah, there's just a bit of a mix and match between Unity versions and the Google SDK version to get it right without you having to code for no reason, just to get the basics to work. So the versions I use, if you're going to go to Android, it will work good. If you're going to go iOS, just go a couple of versions of Google SDK down from what I'm using. Yeah, so this directional vector here is limiting the y, limiting the height, but it's letting the player do what the hell they want on the x and the z. Yeah, x, horizontal, z, forward and backwards. And then now we're telling the player to move. So we're saying the camera rig, again, I have to reference the parent object to move this VR player. So the camera rig, the parent object's position plus equal. So we're going to increment to it. Anything x where you're looking, anything z where you're looking, multiplied by speed. You know, speed is one of our float variables, and then you do the whole time delta time multiplication just so it's not going bonkers. If I take this, I'll show you what happens. Because this computer I've got is quite beastly. Sometimes if I remove time delta time, yeah, it just goes nuts. Yeah, look at that. And I'm probably still going, I'm like 7 miles an hour, but it's like I'm going 100 miles an hour. I've gone through the finish line and didn't even care. Did I have a finish line? Yeah, I had a finish line. It just was too fast for the finish line. So, yeah, add your time delta time to add some reality to it. Now, this bit of code here it's going to make the VR camera, not the bike, but the VR camera, which is the parent of the blue bike, it's going to make it stay inside the road. So if the transform position, and I'm not saying camera rig for now, but if the transform position is less than 4.5 meters, which basically means left side, then it's just going to push the camera to 4.5 meters. If it goes too much to the left, it's going to push it back into the bounds. You could even make that be 2 meters and it'll just push it into the middle. And then the same thing to the right, for the right side. Else if. So if it was an else, it would be kind of like a different situation, but it means if the first bit or if the second bit. So else if it's greater than 4.5, so if it's basically, I think my road is like 5 meters in width, so I said if, or 4.8, something like that. If it gets towards the right edge of the road, which is say just over 4.5 meters, it's going to push it a little bit in. It's going to push it to 4.5. Again, it's not going to mess with it. It's just not doing anything with the Y or the Z, because it's just keeping it as it was. Okay, then where are we? Making the bike jump. If input dot get button down fire 1, on the older version of the Google SDK, it was if the code was something like if GVR instance equal, and then you put your brackets. But the reason I don't use that is the old Google VR SDK worked for the magnet. The newer SDK, believe it or not, doesn't actually work for a magnet. Google changed the cardboard to have like an actual, like a button, something that pushes the actual screen. So what this means on your computer, it will actually work as mouse. You could also just tell it to like, double pipe means, or something very bonkers. So you can just tell it like, that's why. Or you can tell it like if input dot get key down. Let's imagine that fire 1 didn't hit your mouse. You could just tell it or space key. Yeah. So let's just test to make sure I didn't mess anything up. Now I'm going to hit space key. Yeah. Yeah. See, I hit space key. It does it as well. And that this double line thing means or. So we're telling the bike if you've hit your Google VR button on your headset, or you've hit the mouse because fire 1. I can't remember if that actually works as a mobile touch. I can't remember that. Or if actually, I think it did work as a mobile touch when I was trying it on VR. Or if you hit space, we're going to get the actual bike. I've referenced the bike up there. So we're going to get the bike's rigid body, yeah? So I've added rigid body to the bike. That will give it gravity. We're going to add force. So this is some physics thing. It's, we're going to add force, which is kind of like an explosive reaction, but we're going to go in the transform up. So again, I don't need to calculate the maths because transform up would be like a 0, 1, 0, because 0 is X. The second thing is the Y, so 1, and then the third thing is the Z. So we're just going to go up on the Y, and I'm just timesing it by like 1,000 F. Again, I could have made this a variable like force magnitude or something like that, but I just put a hard-coded number in there. And we're also going to decelerate the bike. So minus equals deceleration. I've made a deceleration float variable there, but in the Unity editor, or in the player, yeah? Yeah, deceleration is 2 miles an hour. So yeah, in summary, when you press the button, it's going to jump by adding force. That's a good way to nitrous. That's a good way to jump. It's a good way to shoot a bullet. It can be used if you're making particle explosions as well. And then we're going to decelerate the speed. So we're doing multiple things in one block. But you see, look, we're just killing that if block off there. How we're going to make the bike stay inside the road? It's exactly the same as that. But every time you get towards the edge, yeah, so let's just do some commenting here. When you get to the left edge, or you get to the right edge, I've gone a bit more aggressive with the bike, because remember, this bike's got physics attached to it, and I've had it like 5 on the mass instead of 1, and it's colliding with like the enemies. I think I put rigid bodies on the enemies too, so it's actually hitting them and reacting to how it hits them. Even though it destroys them, it still reacts. And the road has got, I think I put rigid bodies on the road as well, so then the road, it has a collision effect with the road. So I had to go more aggressive and say, when you get to the left edge of the road, and most of the time it even figures out if it's dropped off the road, it pushes it into 2F, which is almost the middle. And then I've told it, push it a bit high in the sky. So push it 2 meters up in the sky and push it in front of the camera too. So this is kind of me hard coding my way around the collision physics that's going on. It's just some basic stuff, but yeah, so it's a more aggressive version of this, which kind of makes sense because the bike has collider physics and all that stuff going on. This is another thing I've done. It's not the cleanest thing. It looks clean, but it's not the cleanest way to do it. Just to keep that whole effect of, so the user, you can see and feel the speed when you're in VR. If you go too far in front of the camera, so now look, if the bike's Z position is greater than this, meaning the actual player VR camera's position by more than 12F, so 12 meters, then what we're going to do is we're just going to push the bike back by 0.1 meter. And it's just going to keep it there, so it will never go fast. It's just a bit of a maths hack. If you're 12 meters in front of me, something's going to pull you back by 10 centimeters. And then you'll never go more than 12 meters in front of me. Even if you jump more than that, if you press jump 2 times, you collide, you'll just be brought back. And if you go 2 meters behind me, so let's just comment this, front of the camera, if in front, if behind the camera, front, if behind the camera, if behind the camera. Okay, so if you're 2 meters behind the VR camera, it will just not do anything with the X, not do anything with the Y, but it will push you 1 meter in front. Actually, no, I'm not going to mess with it because I'm trying to just hack my way around the physics. If sometimes you do one thing wrong and then you just have to spend ages trying to fix it. This is something that whenever you set up, so in my other tutorial, it's going to show how to set up the Google VR, like get the SDK in and all the tweaks and hacks you need to do to just make it work. One thing you want to do is you want to make sure raycasting is working, because a lot of the time you can use like lasers that are coming out of the camera, and you can use those to trigger. So this is, this worked, but I commented it out because we don't need it for this game. Okay, so just to refresh after everything we've seen, assuming I haven't done anything wrong with the code, you should start to make more sense about what's going on. Enemies are spawning, roads are generating, there's the finish line there if we need it, and the game manager script we're about to go into show you the finish line. And then you've got this this motorbike that you can control your mouse, you hit the finish line. The score won't change if I hit anything after anyway, because we kill off everything when you hit the finish line. So let's go to the game manager, the last bit, and then we're done. We saw this spawning enemy stuff, so we can ignore that. As you'll now know, if you didn't already know, this is how we're referencing some objects and codes to come in from other places. We've made a text mesh. I've called it UI text. That's what's going to be used to, where is it? There. I've put it inside I've put it as a child of the player, not child of the bike, but child of the player. So that way you just see everywhere you are. Standard hack thing, make it be middle center on the anchor and center on the alignment. Doesn't really matter what you put here because we're programmatically going to change that. So we've got this text mesh thing. We've got a game timer, a final timer. You can imagine you can create integers or floats, and you can just get this, time.delta time to keep adding or decreasing from it. We've got a final score. We've got that game over boolean. We've got a game over timer to reset the game. We've got a finish line game object. I know a lot of people put all of their game objects at the top, their privates at the bottom, but I kind of like to chunk and block everything together so when we're going through it, we can figure out what it is. And we've got a finish line position. So you can, let's imagine you had multiple levels. The better or the further the player gets along the game, you can just make each level have the finish line closer and the speed go faster, or the other way around. So what we're going to do, we are going to reference the finish line, just to import the finish line into the game manager, or you could just, like a normal person, would just drag it in from the Unity editor. And then we're going to set the position to the finish line position. So we're going to say, again, don't worry about the X, don't worry about the Y, the Z distance. So assuming you've already put the X and the Y position in the right place, we're just going to change the Z position. Yeah? Start off at 200. You can change it whatever you want in the editor. Again, if you're baffled when you're watching this video or after, just check my comments. Sometimes my comments are after the line, but location to place the finish line object. Then what we're doing is we've already covered this. The next thing we're going to do is we're still inside update. What we're going to do is we're going to make the game timer keep increasing, and then as you will recall, the UI text reference the time, how far you've gone along in the game. So if is game over is false, which means if you haven't hit that finish line, make the text, the UI text.text, make it say time and then the game timer. What this mathf .floaterInt means is the game timer is a float, so it will look a bit bonkers. Let's just see what it is. It's going to look bonkers if you don't convert it to like an integer or something. You don't have to. I'll show you. Yeah, like, what the hell? You could just round it down to like 2 decimal places and it looks quite cool and it's a bit more accurate. But, yeah. So what you do is you're telling it to get the game timer, convert it to an integer, then get the score from the player.score. I believe we have already referred to how that score is generated. It was inside the bike collision if the enemy is hit. Some people also do a not null just to double check it's been hit, but I don't do that sometimes. If the enemy's hit, the score goes up. So in the game manager, what's going on here? Yeah. After it tells you the time, it tells you the score, and then we're referencing the player.score because I've told it to get the player's code. So we can just get it by typing player.score. We don't have to write that really long line. Like sometimes I had to do like this stuff because I didn't reference the code. I only referenced the game object, referenced the code. So when I didn't reference the code, I had to go to the game object, go to the component, go into its class, and then find the code from there. It's like long. And then we have got speed. So the speed again comes from the player. And as you will recall, as soon as you're an update, speed is just going to be incremented not by time, but by acceleration over time, as in multiplication over. So if the finish line is true, yeah, then what we're going to do is we're just going to, if the finish line is true, we're not going to do different things yet. We're going to just change some settings. We're going to set game over to true. We're going to make final time equals game timer. So we're going to take a snapshot of the game timer and make final time be that. We're going to take a snapshot of the score, and then we're going to make the final score be that. So that way, if the player was to do anything while the game is over, it won't change the score that you see, because else means if this stuff ain't true, then do this. So if game over is true, then you're going to do this. Because what we're saying is if game over is false, do this stuff. But if game over is not false, then do this one, because it's an else, not an else if. And we've already set this stuff here. So we're going to change the text to be game over time, and now it's going to be final time. Not game timer. It's the snapshot. Score. It's final score. It's not player.score. It's the snapshot. So we've taken the score from the player script, and now we've injected it into the game manager script. And then restarting in, and then we've got a game over timer. Yeah? The game over timer is over here. It's just, when it updates, it's going to just keep checking. So it doesn't matter if it's below. Like normally with code, you want to write it top down. But we're in basically an endless loop, almost an endless loop. So the game over timer is going to minus equal delta time, but it only starts to take place in this else block, and we set it here as 4.5 seconds. And then when game over time is less than or equal to 0, it's going to do all of this stuff. What this stuff means is basically restart the active scene of the name of the scene what you're in right now, and that's coming from a different thing that doesn't come standard in your it is part of, say, Unity and game engines. Sorry, something is missing up here. Not good. Let me try to find it. It's not, anyway, this thing called scene management, you have to write it in yourself, so you can just do Unity engine, duplicate that and write .scene management, and then you can start to get all the scene manager type things. And that's basically it. So let's play. Let's clear those errors, fake errors. Oh, let's make it look a bit better up the top. And I saw something that doesn't look completely right. It's just some aesthetic thing. If you look at score, the 0 is practically touching the colon. So let's solve that by going into Game Manager. And this is while the game is running. Yeah, so we just need to put a little space there. Alright, let's do this. Now after all of that, hopefully it makes sense and you know how, the basics of VR work. As well, we just get off the cliff so we can start again. So if I just keep jumping, I'll go into reverse, because every time I jump I'm losing. This player is still in the air. And it's going with, you can see it there. There you go. So now it's going to, it's gone. I'll do that again, but less aggressively. Speed increase, speed increase, speed increase, and enemy score counter goes up. Speed increase, speed increase. If I jump, I'm on 20. I'm on, go down in speed, and then I hit the finish line. When you hit the finish line, the Boolean changed. I was going to pause it, but you could actually see the Boolean. Who's got the ball? I think the player's got the ball. Yeah, reach finish line. So if I just tick that, yeah, so you could be in the game. So I'm in the game. If you look at this bottom screen, I'm just going to tick reach finish line, and it triggers the game over. It slows everything down. Did I even skip past that? Oh yeah. So when the game is over, also the last bit, I've told the player's speed to go right down to 0.3 miles an hour, and the max speed to be 0.75, and that just creates this effect. Like if you play Tekken and you knock somebody out, you can still do something for a few seconds. So it does that. So let's get to that effect. So if I flip this to true, like I can still move around, but I can't really move, and I want to change my score counters either. So yeah. That's how endless runners work. That's the basics of VR and some game development. And yeah, just drop me a comment on what type of tutorials you want. I've got a few more VR ones coming up soon. See ya.